that you could do with a piece of a circle is to find the area of something called a sector. Now, last time we said arc length was like the crust of the pizza. Well, the sector is like where all the cheese is and all the toppings. So, just a reminder, just going back to finding the arc length of a circle, using that angle measure, S is equal to R times theta. Here's another example of it. So imagine you have two gears are adjusted so that the smaller gear has a radius of 3.6 inches and drives a larger one with a radius of 5.4 inches. If the smaller gear rotates at an angle of 150 degrees, how much did the bigger gear, how many degrees did the larger gear rotate? So if you'll remember that since it's a smaller gear, even though one is smaller than the other, they should share the same S. So whatever S that they're going to go the same distance. So the question is, how much did the bigger one go? Obviously, not as much as the smaller one, because the smaller gear has to work harder to get around. The bigger gear just takes its time. So to find the small s, then first of all you have to change the 150 into radians. So you have 150 times pi over 180 is equal to 5 pi over 6. So the radius of the small one is 3.6 times 5 pi over 6, which is equal to 3 pi. Just to simplify that out. You multiply by pi, you would also, let's multiply that by 3.14 and you get that without pi as well. So since they travel the same distance, right? So since this is the same distance as this, then the big S will be the same. The big S will be the same as the small s. And now we just have to find the angle for the big S. So using that 3 pi as your S, we have a radius of 5.4 times theta, because we don't know what that theta is. So when you divide by 5.4, you got 3 pi over 5.4 is your theta. Now, since the angle, that's in radians, since the angle was given to you in degrees, you can convert this. So 3 pi times 5.4 times 180 over pi would give you about 100 degrees for your theta. So again, when it comes to gears, the distance that they travel should be the same no matter what the size of the gear is. The distance around it should be the same. So they should share that same S. Okay, now on to sectors. Here we go. A sector of a circle is the portion of the interior of a circle intercepted by some central angle. So, for example, let's say you have some center, there's some central angle, there's your radius, right? And of course, you would have some angle. The sector is the area inside that angle. So if I would take a highlighter, let's highlight, there you go. So that would be a sector. Now, a couple things you have to remember. Area of a circle is pi r squared. Pi's aren't squared, silly, they're round. No, that's my favorite. Area of a circle is pi r squared. So, and you know that a circle is 360 degrees, or 2 pi. So part of a circle is going to be whatever angle, so theta over 2 pi times pi r squared. And that would just cancel out the pi's. And mixing it around, this just becomes 1/2 r squared times theta. And that's how you find the area of a circle. So you're just dividing out the circle based on how many, what the degree of the angle is. So with theta in radians, the big equation for today is 1/2 r squared times theta. All right, let's practice. Finding the area of a sector with a circle having a radius of 15.20 feet and a central angle of 108 degrees. And right off the bat, you got to multiply that by pi over 180 because your theta has to be in radians. So 3 pi over 5 is what that comes down to. All right? So your area is 1/2 r squared theta. Plugging everything in. R is 15.220 squared times 3 pi over 5. You can change all that to decimals if you want. Go ahead and pause the video and calculate it. And you should have gotten 217.8. We're talking about area, so your units are squared, so it's feet squared. All right, if you take a look at the back of the page, it's kind of a mix of all the formulas that we've talked about so far. Go ahead and give yourself some time to practice those problems, and when you're ready, pause the video to practice, and when you're ready, go ahead and bring it back up again, and I'll show you the answers. Okay. Hopefully you had some time, and as long as you did it right, hopefully it'll be the same thing. I left my answers in terms of pi, so if yours is long, just divide pi out of it, and or just multiply my answer times 3.14. So 16 times 3.14, that would be the decimal answer for that one. So 16 pi is 1, 70 pi is number 2. You're going backwards and find the angle, so 60 degrees for 3, 240 degrees for 4, and in radians, the angle in 5 would just be 1. Let me know if you need any help. Go ahead and text me on Remind 101 or take pictures of any problems that you can't seem to follow, and I'll get back to you as soon as I can. Good luck, everyone.